This section examines the principles of the rotary engine. The rotary engine is not as common as the four-stroke or two-stroke engine, but its basic principle is well accepted. It operates very differently from a reciprocating engine. A piston engine is called reciprocating because the pistons move back and forth over the same path. This reciprocating motion changes into rotary motion at the crankshaft. A rotary engine has a rotor, not a piston, and it's called rotary because the rotor has a planetary motion. It does not reciprocate. The rotor is roughly triangular in shape, and it turns inside a housing which is a particular geometric shape called an epitrochoid curve. Because it spins rather than moves up and down, engine operation is said to be very smooth and vibration-free. Let's look at the basic principles of the rotary engine. The rotary engine does look different, but it's still an internal combustion engine. So let's find the 5 key events common to all internal combustion engines. Intake occurs when air-fuel mixture enters the working chamber at the inlet port. The turning rotor then carries it around to the spark plugs. Along the way, the volume of the working chamber decreases and compresses the mixture. The mixture is ignited and combustion occurs. Expanding gases produce a power pulse driving the rotor onward. When the exhaust port is uncovered, exhaust occurs as the rotor sweeps burned gases out of the housing, which brings it all back to the beginning, ready to run a new cycle. Let's look at the rotary engine's major parts. The rotor is mounted in an oval-shaped housing. The housing is made of aluminium alloy, but the curved surface has hard chromium plating. This surface has to put up with the wear and tear of the rotor sliding against it as it turns in the housing. There are usually 2 spark plugs fixed to the housing which enable combustion to occur. The rotor housing also has an exhaust port to expel burned gases. It has cooling passages for water to circulate. The rotor has 3 apexes which have seals to seal between the rotor and the rotor housing. This prevents premature wear as the apex seals and housing are in continuous contact. Side seals seal between the rotor and side housing. The combustion chamber is formed by hollows in the flanks of the rotor. These hollows are sometimes called bathtubs. Front and rear housings, or side housings, are bolted to each side of the rotor housing. If it's a 2-rotor engine, there is an intermediate housing between the 2 rotors. An internal gear in each rotor meshes with a corresponding stationary gear in the front housing and rear housings. When combustion occurs, the meshing of the teeth forces the rotor to walk around the stationary gear. This combines with the eccentric shaft to make the rotor follow the curved surface of the housing, and it gives the rotor planetary motion. The rotor is attached to an eccentric shaft at points called rotor journals. This shaft is like a crankshaft in a piston engine, but with the journals off-centre. Because the rotor is off-centre, the force applied to the shaft is off-centre too. The whole shaft is supported by main journals, so the final output is smooth rotary motion. Let's examine the rotary cycle in detail. The inlet port is uncovered and fuel-air mixture enters the working chamber. The lobe of the rotor covers the inlet port and the rotor moves the mixture around the chamber. The rotor turns. The working chamber becomes smaller, compressing the mixture. It is smallest at the top of the compression phase, and that's when the air-fuel mixture is ignited. Hot, expanding gases apply force to the rotor and produce a power pulse, which turns the rotor. This power impulse is also called expansion. The apex of the rotor uncovers the exhaust port, and exhaust gases are pushed out of the chamber. This completes one cycle. In rotary engines, the stages are called phases. So one engine cycle has 4 phases. How does the output of one rotor compare with the output of a piston engine? Look again at the working chamber. How many of these chambers are there in the housing? There are 3. 3 working chambers between the rotor and housing, and 3 lobes on the rotor. This means that for each complete rotation of the rotor, there are 3 power pulses. Let's see how this occurs. Start near the end of an intake phase for working chamber A. Apex 1 is compressing the fresh fuel-air mixture as it approaches the plugs. At the same time, chamber B has ignition and combustion, and the start of a power phase. Chamber C is full of exhaust gases being pushed out of the open exhaust port. The mixture in chamber A keeps being compressed, getting ready for ignition. Chamber B has uncovered the exhaust port and is starting to push out its exhaust gases. Chamber C has moved on for more fuel-air mixture. Chamber A ignites. The combustion produces a power phase for A. Chamber B keeps pushing out exhaust gases. Chamber C's inlet port is about to be closed after receiving more mixture. Chamber A moves on to push out exhaust gases. B gets more fuel-air mixture, and C approaches ignition. A finishes discharging exhaust gases and moves on for more fuel-air mixture. B is at ignition, and C is pushing out its exhaust gases, which is where we started. The 3 chambers continue in different phases. The top chamber is in intake, the right chamber is in ignition and power, and the bottom one is in exhaust, all at once. Each chamber has 1 power pulse, so each rotor revolution produces 3 power pulses, which is similar to the output from a single-cylinder 2-stroke engine. What if 2 rotors are bolted together? Then their output is similar to that of a twin-cylinder 2-stroke engine. Because of the ratio of the gears in the housings and rotor, the eccentric shaft makes 1 revolution for each power phase. That's the same as 3 revolutions for each rotation of the rotor. So the eccentric shaft turns at 3 times the speed of the rotor.